A diagonal fracture on a transmission countershaft is one of the most difficult failures to fix because the repair has to withstand immense shearing force and rotational torque. Most mechanics would tell you this part is garbage, but we are going to use an internal bridge technique to make it stronger than it was before the break. The process begins on the lathe. We mount the main body of the countershaft and use a facing tool to create a perfectly flat surface at the break point. Once leveled, we use a center drill to start a pilot hole. This hole is then bored out to a specific depth and diameter. This cavity is where the new heart of the shaft will sit. To ensure a mechanical lock that won't slip, we use a threading tool to cut deep internal threads into the bored hole. This requires extreme precision. If the threads are even slightly off-center, the entire countershaft will be unbalanced, leading to vibration and eventually destroying the gearbox. Now we move to a fresh piece of high-tensile iron. We are machining a custom connector piece that will act as a bone graft between the two broken halves. We turn down the diameter to match our internal bore and then cut external threads that will perfectly mesh with the ones we just made in the shaft. We also machine a shoulder on this piece to provide a solid stop point. With the connector ready, we apply a high-strength lubricant and screw it into the gear side of the brake. Once bottomed out, we take the other half of the broken shaft and press fit it onto the remaining end of the connector. This alignment is the most critical part of the job. The gear teeth on both sides of the brake must be perfectly timed and indexed so the transmission shifts smoothly. Even with the threads holding it together, we need a permanent fuse. We use an arc welder to lay down multiple heavy beads around the circumference of the brake. We aren't just filling the gap, we are ensuring deep penetration into both the original shaft and the new internal connector to create a single unified structure. The welded shaft goes back onto the heavy-duty lathe. We turn down the rough weld beads until they are flush with the original shaft diameter. This removes any excess weight and restores the balance. After the turning is done, we use a handheld grinder to carefully clean up the profiles of the gear teeth where the weld might have interfered. After a final polish and a coat of protective paint, the countershaft is indistinguishable from a brand new part. The internal iron bridge provides the core strength, while the external welds provide the skin tension. This part is now ready to go back into the transmission and handle years of heavy-duty work. This is the difference between a simple patch job and professional engineering.